This week in science, we have a quick check today, and we are finally back on track with our live lessons and your lessons in Connexus. So from here on out, you should be able to complete your lessons in class and not have anything overdue. We were kind of disconnected for a little bit because of our little hiccup we had with Zoom. So today we'll be working on Quick Check 3.6, which is the solar system scale. And then tomorrow you have a quick check on gravity. That's 3.8. If you want to complete that quick check in class, then you can go to Dr. Fowler's class on Friday. She will be doing that one. So both your science lessons are being done in live lesson this week. So you can just attend class and get them both done. There is one other thing I wanted to point out. So let me just show it to you in the planner. Hang on. Because you have a portfolio coming up. So we have had one portfolio before, and the next portfolio is due next week, which is on Monday. But as you may have noticed with the first portfolio, they take a little bit longer than like your quick checks do. So I just wanted to point out that your next portfolio is due a week from today. It's on your planner for Monday the 18th. And the lesson that it's in is titled Solar System Apply. For your portfolios, it's really important that you read the lesson intro page because it tells you to skip the whole lesson and just go to the last page to complete your portfolio. Some of you guys did a lot of extra work on the last portfolio because you did not skip the pages that we told you to skip. So don't do more than you have to do. I mean, I love the overachieving. If you want to, go right ahead, but just be aware that the only requirement is the last page of that lesson. So that is due on Monday. Since you only have 2 quick checks this week for science, I would encourage you to get started on that portfolio this week. Okay. You will have to access it from next week on the planner, but you can go ahead and start it as soon as you finish this week's lessons. And then, of course, we'll be doing it in class. Dr. Fowler will be doing it in class on Monday of next week. So you could also wait and just do it with her then. But I did want to give you a heads up that that is coming up. So just be aware. And it's kind of important for you guys to work on your time management. I don't know if you've realized that in our school setting, that's kind of an important piece. So if you kind of know what needs to get done by the end of the week, it could help you organize how you spend your time during the week. Nyla, I see you have a question. If you could just send it in the chat, please, then I can answer it. Okay, so that was just a heads up that we have the portfolio coming up for next week. And then also the live lesson schedule for this week. You're with me today. We're doing 3.7. We do not have a science live lesson on Thursday because I will be at the welcome event in Macon. I hope to see some of you guys there. And then on Friday, Dr. Fowler will be doing the 3.8 quick check. I had a question in the chat that I think is something everyone might want to hear. Will you have a higher grade if you do the hands-on portfolio versus the virtual portfolio? And the answer is no. They're worth the same amount. Okie doke. So let's go ahead and get started on today's quick check. So today's quick check was called the solar system scale. And the idea of the lesson today is how we model things like the solar system that are just so big, we can't really see them or interact with them in person. So we create scales. So I just wanted to show you kind of a quick clip of what a scale is.
Build custom industrial machines in days.
I feel the need
The need for speed.
So this is just an example of a model. It is one of the planes or jets that was used in the movie Top Gun. And this is actually a hobby that a lot of people have, where they create like, exact replicas. But the idea of a model is that if something is a certain size in real life, you create a scale to represent that size. So if the jet is 500 feet long, then in this model, the jet would be maybe 5 inches. So 1 inch represents 100 feet. So that's the size behind it where you have to be accurate, because your scale needs to make sense and it needs to be consistent in your model.
Great.
All right. Could y'all hear me when I was telling you that? Did I mute myself? Oh, okay. Sorry. I'll repeat that. So what I was saying is when you are building a scale of something, oftentimes it is representing something that's so large that we can't experience it in real life, but it could also be representing something really small, that it's so small that we can't see it. But in this example with the jet, the idea of a model is in real life, if that jet were maybe 500 feet long, in a model, you would have to determine a quantity to represent that 500 feet. So in this model, it's very small. So it would be maybe inches. We usually try not to use inches in science because that's an American measurement and we want to stick with metrics. So you'll oftentimes see centimeters, millimeters, that type of thing. But if this model was representing a 500-foot jet, in the model, each foot would be represented by something much smaller, like a millimeter. And then you have to be consistent with your measurements throughout your whole model. Okay. I'm going to put the chat on hold just for a minute while we discuss the lesson, and then I'll go back at the end and answer questions. Okay, so before class today, I had sent out a Padlet, and I asked you guys if you had any interest in like Legos or models or things like that, because Legos are an example of a scale model. So I wanted to see if you had done any and asked you to post on this Padlet. So let's see. We have some posts. We have a post about a giant Lego. So this is just a photoshopped photo, but if it were to really exist and there's a giant Lego man on the Arc de Triomphe in Paris, this would be an example of making a model of something very small in a much larger way, which is, that's true. It's a type of model. You can go bigger or you can go smaller. This is awesome. I think this is the Harry Potter world. Is that right? No, it's a ship. What is this one? There's no comment on it. I'm not going to send out the link because I had to preview the post before class. I had sent it out on Friday in a webmail to everybody. So I'm just showing you what people posted. I'm not sure. I think it was Harry Potter. That's the first thing that occurred to me, but it could be a ship. But anyway, this is a really good example because you have this huge, very intricate castle that most people can't go to actually see. Now, one reason you can't go to the Harry Potter castle is because it's fictitious, but they actually did make a model of it at Universal Studios in Florida. I have unfortunately not had the privilege to go there. Maybe some of you have, but it's on my bucket list. But anyway, since most people can't go there, one other way to experience things is by looking at them in a model. So this is a smaller example of a large structure. I guess that's the little Lego girl. Here's another example of a model. I don't know specifically where this is a model of. I see a dragon at the top, so I'm assuming it might be from another book. But you can see how this very large town is represented in a much smaller scale. And then, of course, the science again behind it is there would be a metric conversion. So, like 1 centimeter would equal a certain amount. I don't know specifically for this example what that measurement is, but that is also a very important part of models. Oh, okay. Another Lego example, the ice cream truck. Obviously, an ice cream truck is going to be very, very large. So just an example of how we can use a scale model to make it smaller and more manageable. Apple. And then another Lego example. Do y'all still do Legos? They make them for adults, so there's no shame in Legos. They make some really cool like landmark ones. I've seen some of the monuments in New York City. I've seen some really cool cars. There's like a whole line right now where you can build the super nice cars like Lamborghinis and what was the other one I saw at the store? What's the other one that's like Lamborghini? My son would be mad at me. I forgot. Anyway, you get the point. So thank you for those of you that posted on there. Always look out for webmails from me. You never know what they might say. All right. So again, the point of a scale model is to make something that's either very large, manageable, or very small, manageable. And our big examples for your lesson were the planets in our solar system, also the part of an atom. Atoms are the building blocks of everything, of all matter, but they're too small for us to see. So by building a model, it allows us to envision what it would look like. Okay. Whoops. Okay. Here are some other examples. Again, solar system. Up here on the top, you can see a Rolls Royce, and you can tell how small it is because the man's holding his hands by it. Some examples of a giraffe over here. And I like this example because it shows the mathematical scale. So see here at the top where it says 1 equals 5. So for every 1 inch on the real life dinosaur, it's I'm sorry, for every 1 inch on the scale dinosaur, guys, sorry, giraffe, that 1 inch represents actually 5 inches on a real life giraffe. And so we have an accurate number here to tell us how that scale is made. Okay. And then, yes, Ferrari was the other one. Thank you. And then over here on the bottom, again, we see a scale that has our numbers. So you have the size of a football. And then in this example, all of the items are smaller. So we have blood cells, we have viruses, bacteria, and I don't even know what that smallest one is. But again, those are things that we could not see just with our eyes. So making a model of them helps us understand them. All right, so let's try it together. We are going to be making just a practice model of the solar system. So if you want to, you can use paper and pencil at your house. This is not a required assignment. This is just to practice with what a scale is. I'm just going to let some other people in the room. You can use paper and pencil. You can use actual like physical items. Like if you have small, these are like little tiny Legos. You could use things like just stuff you have around your desk. Like I have an eraser here. I have some coins. Like that would be a good tool to represent something else. So just be creative. It's nothing, there's no wrong answer here. It's just to kind of practice using a scale. If you'd like to use the whiteboard, I'm going to send you a link. This is just to the it's not the whiteboard in Zoom, it's a separate platform. If you want to use that, then you could. So let me get you this link, just a sec. It is. Okay. And then an important piece of creating a model is to have the measurements of what you're trying to model available to you. So I'm going to send you the whiteboard link in the chat. If you want to use it, you can. Again, you don't have to. You could just watch. You could use paper and pencil at home. You could use items. Just a chance to kind of be creative. But if you want to use the whiteboard link, I did send that out. So while you're figuring out what you're going to use, I'm going to pull up the measurements of the planets in our solar system. And we're just going to look at them by diameter today. This was actually in your lesson, so you could go back into it and look. I'm just going to pull it up online. Okay. So here is some information about our planets. So if we're looking at diameter, for, oh my gosh, look, they included Pluto. That was so nice. We don't usually include him. And they also include the moon. Really, we're just looking at our actual planets. So Mercury's diameter is 4,879, and then this column is kilometers. Kilometers are a metric measurement. We do want to stick with metric. Miles are American, and if you go anywhere else in the world and talk about miles, they will not know what you're talking about. If you go anywhere else and talk about kilometers, they will. So scientists like to use common language that everyone, regardless of your actual language, can understand. So we do stick with meters whenever we can. So Mercury is 4,879 kilometers. That's approximately the distance from the west coast of the United States to the east coast, so like from California to Maine. Then Mars is 6,792. Venus, Earth. What do you guys notice as I'm going down this column? What's happening to our numbers as we get out to our gas giants? Yeah, I can put it in the chat. Good job, Joshua. They're getting bigger. And that is something that you probably need to be familiar with. The inner planets, the terrestrial planets, are smaller, and then our gas giants are larger. Okay, so if we're going all, and we're not going to include the sun in our model, let's just include the 8 planets that we recognize: Mercury, Mars, Venus, Earth, Neptune, Uranus, Saturn, and Jupiter. With Jupiter being the largest at 100, no, yes, 142,984 kilometers. Okay, so how could we represent that on a drawing or on a physical model or your pencil and paper? How could we represent that big of an object? If our measurement is, and I'm going to put it in the chat, if our measurement is 142,984 kilometers, what kind of measurement could we use to represent that we could actually manage, since we can't manage that big of an area? Let me get well, I had a ruler, but I think my daughter stole it. Never mind. Centimeters. Good job. Is it Elin or Ellen? You have to let me know how to say that correctly. So yeah, we can represent that by centimeters. So how many, if we have to represent 142,000 kilometers, how many centimeters might we want to use to represent Okay. How many centimeters could we use to represent, or how many kilometers would 1 centimeter represent? 5 to 12? Okay. So if we did 5 to 12, then we would have to divide 142,000 by 5. That's going to give us how many centimeters? Let me get my calculator out. That's too much math to do in my head. That would be 28,400 centimeters. So that's still a really, really big amount of space. We probably even need to go smaller. So we could even do 1 centimeter that represents, let's say, 10,000 kilometers. Okay, so I'm going to write that down so I don't forget. So 1 centimeter equals 10,000 kilometers. Let's just start with that. It might not work. That's okay. It's part of science. We're going to see if we can make a scale where we can represent the planets with a scale of 1 centimeter for 10,000 kilometers. Yes, you could do millimeters too. That's true. And they are smaller, so you would be able to get more in. But let's just stick with this. And then let's start with, how about our smallest planet? So we made our scale with the thought in mind that we have to accommodate our largest planet, which is Jupiter. But let's start our scale with our smallest planet. So what is the diameter of our smallest planet? You don't have to do all the planets, but you could, Jakari. Let's see. I think I know which one's the smallest. Does anybody know which planet is the smallest? That's okay. Pluto. We're going to stick with the 8 we recognize. So Mercury, thank you. And what is our diameter for Mercury? Right here, it's telling me 4,879 kilometers. Now, if I were submitting an assignment or working for NASA, I'm going to calculate 4,879 kilometers into centimeters. For the sake of our class, we're going to round, and that's perfectly fine. So we're going to round to the nearest thousandth, which is 5,000. So if Mercury is 5,000 kilometers, let me write that down. How many centimeters would that be? So if 10,000 kilometers is 1 centimeter, then very good. It would be half of a centimeter. So Mercury, we would take our ruler and we would measure half of a centimeter. Let me get some better paper here. Hang on. We would measure half of a centimeter circle to give us our Mercury measurement. Let's see here. Okay, so I get my centimeter out. Let me see if, So Mercury would be about that big, like a freckle, maybe a mole. Okay, little old Mercury. He's so cute. Okay, so remember, this is nothing fancy. You can do it on your own whiteboard on the screen. The whiteboards sometimes are hard to use the drawing tools on. Um, some of you are doing a really good job. So you can use paper, you can use whatever you want. If you're using something like an actual item, then you probably want to find something like super duper small to represent half a centimeter. That is Mercury. I don't even think I have something that small. Like a crumb from my lunch, maybe. Okay, what's our next planet? If Mercury is 4,879 kilometers, which planet would come next in size? Mason had a good question. How big would Pluto be if Mercury is that big? Well, Pluto is almost half the size of that. So, really small freckle. Which planet is the next largest from Mercury, according to our chart? Did I ever put this in the chat? I can't remember. I have a couple people saying Mars, some people saying Venus. Um, it is going to be Mars because Venus is 12,104 and Mars is 6,792. So let's round Mars up to about 7,000. How many centimeters would 7,000 kilometers be? That's a little bit more math than last time. It would be about like, so if 5,000 is 0.5, it's going to be 0.7, right? So 7,000, whoopsie daisy, kilometers equals 0.7 centimeters. So my next measurement would be just a little bit bigger than my first one. Okay. Let's see if anyone's got some good drawings going. While I'm looking, what's our next largest planet after Mars? I like Summer's purple dot. That's nice. So the next largest would be, have you noticed that this is going in order? Venus is 12,104. So let's go back to my whiteboard. Oops. How many centimeters would that be? We can round this to just 12,000. 12,000 kilometers would it be? Any guesses? How many centimeters with our scale? Good job. Thank y'all. 1.2. So we're going to go just a little bit bigger for Venus. I'm literally just making dots. That's how simple a model could be. But the important thing is it's accurate with the measurement. Okay, and then after Venus, have you ever heard that Earth and Venus are called twins because of their size? Earth is 12,756 kilometers. So we could really round that to 12,000, let's see, or to 13,000, just to give it a little bit more difference from Earth. So how many centimeters would 13,000 kilometers be? Good job, guys. Some of you guys are really participating, and I can tell in your grades that you're paying attention. So that would be about 1.3, which is really going to be very close to the size of Venus. And that gives us our inner planets, right? And remember, we refer to them as terrestrial because they're Earth-like, because they have a hard surface made of rock. Now let's go on to our gas giants. I'm just going to delete this just for space. So our next largest planet is Neptune at 49,528. I'm going to round that up to 50,000. So 50,000 kilometers. How many centimeters is that going to be? Good job, guys. That would be 5. Good job, Skylar. Good job, Elin. Very good. So I'm going to use a ruler to measure 5 centimeters. And then I'm going to make my circle. Oh, I need to label Neptune. Okay, see how much bigger Neptune is than like Mercury? That's this part of the standard that you guys need to know. You need to be able to compare the planets to each other. So let's keep going. What's next after Neptune? Uranus is 51,118. We could round that to 51. So we're not going, and I had a really good question in the chat. She said, I thought Jupiter was a first gas giant. You're absolutely right. It is the first gas giant in the order from the planets. But if we're putting them in order of size, it's not next. So that is a difference. Yes. So if we're looking at them from the order from the sun, Jupiter would be next as the first outer planet, but we're looking at them in the order of size, and after Neptune would be Uranus. And so 51,000 would give us 1, 2, 3, 5.1 centimeters, which is going to be really similar to Neptune. And then next we have Saturn. Saturn is 120,536 kilometers. So we would round that up to 121,000. Good job, Elin. 121,000 for kilometers, and our scale would be 12.1 centimeters. So the last one we did was 5.1 centimeters. It's going to be more than twice that size. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's Uranus. See how big that is? And then of course we have our biggest one of all. Let's see what I can remember what Jupiter's measurement was. We talked about it already. 142,984. So we would round that up to 143,000. And what would that be in centimeters? Right, 14.3. Great job, guys. Always like to sneak some math and science. So I'm going to do 14 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.3. And that's going to give me Jupiter, which is way bigger than all of them. See? Look at the size compared from Jupiter to Mercury. And I wouldn't even have enough room on my whiteboard to draw the sun. That's how much bigger it is in all of them. And then the crazy thing about that is it's not even that big of a star. So anyway, good job. Thank you for working with me and including math and science. It's always fun to learn. Good job. I'm just looking at y'all's. Nice. I like the colors. Using the tools of the whiteboard. Very good. Wonder if anybody used actual items in their house, like I was showing you as an example. All right. So we can use that information to complete our quick check. There are 4 questions in your quick check. I'm going to give you a minute to go ahead and get to your quick check. If you haven't already done it, go ahead and get there now. We can do it together. And it's a guaranteed 100 when you do it with me in class. So just take a minute to go ahead and pull up your quick check. It's 3.6. It's on your calendar for today. Yes, if you've already done it, you're welcome to leave. You never have to be in class. It's always your choice. Yes, it should be on Monday for today in your planner. Right here. Solar system scale. All right, our first question. A student uses a diagram to show the scale sizes of the planets. which planet's diameter would be approximately the distance across the United States? So we actually did just talk about this, but it was also in your lesson. So out of your options, Uranus, oh, I shouldn't have erased my board. Mercury, Jupiter, and Neptune, which one of those would be closest to the size of the United States? Remember how big our gas giants were compared to our terrestrial planets? So we can take away pretty much all the gas giants. And what are we left with out of our options here? Thank you, Phenomenal. Thank you, Elin. Mercury would be the correct answer here. And we can actually see this in the lesson on page 3. I think it was page 3. It showed you. So that's not something that you would be responsible to memorize for a test. You would just be given the data as part of the question. So since you were completing the quick check, you could have gone back to the lesson to help you find that answer. So that was Mercury. And that makes sense because Mercury is a pretty small planet compared to the others. Okay, so question 1 is Mercury. I think your questions are in the same order. I don't know if your answers are, so just be careful with your answer choice. So Mercury for question 1. All right, question number 2. Suppose a student develops a scale model of the planets. Well, we just did that. Which 2 planets should be the closest in diameter on the model? So out of the model that we just made, which 2 were closest in size? If you miss a question, you have to watch the recording and go back. We don't have time to repeat each question. So if you don't remember from our model, you could still look at the data right here. Which numbers are the closest together? We have 4,800, 12,100, 12,800, 6,700, 143,000, 120,000, 51,000, and 50,000. Well, 51,000 and 50,000 are close, but there's 2 that are closer. And that would be 12,100 and 12,800. Good job, Evan. Good job, Lola. Venus and Earth. So these are your answer options. Again, yours might be in a different order, but the 2 that are closest together or closest in size for diameter are Earth and Venus. So take a second to answer that. Question number 3. A student creates a scale model of planets where 1 centimeter is equal to 10,000 kilometers. Well, we just did that. In this model, which planet would have a diameter of approximately 12 centimeters? So if we think back to our whiteboards that we just made, we could also look at this diagram again. Which planets would have would be represented by around 12 centimeters? So you would have to divide each of these numbers by 10. Good job, Cameron. Cameron says Venus. That's absolutely right. Oh, wait, no, I'm sorry. We have to go to Saturn. Right, it's Saturn. That would be by 10, not 10,000. So the correct answer here, a student creates a scale model of planets where 1 centimeter is equal to 12, or I'm sorry, 10,000 kilometers. In this model, which would have a diameter of approximately 12? That would be Saturn. Earth would be 1.2, remember? So Saturn would be 12 centimeters. And then the last question, which planet will have a diameter that is approximately 10 times larger than Mercury on a scale model? So we need to find what size Mercury is. Oh, I X'd out. Wait a minute. So if Mercury is 4,800 kilometers, which planet would be approximately 10 times larger than that? Well, what is 4,800 times 10? Be 48,000. So which planet is closest to 48,000 in diameter? Good job, Elon. She says Neptune. 50,000 diameter or kilometers is closest to 48,000. So yes, Neptune would be our correct answer here. Good job, Summer. So the last question, your answer would be Neptune because Neptune's diameter is about 10 times greater than Mercury, sorry. All right, so that brings us to the end of our quick check and to the end of our live lesson. If you have any questions, please feel free to stick around. Otherwise, you're free to go. Hope you have a great Monday. I'm not going to go back over the questions. If you missed a question, you can go back and watch the recording. Can you see my dogs? Luna, come here. Come here, Lou. Come here. Hi. I can't hold the other one in my lap. She's too big. Thank you. Magali, we'll do Dr. Fowler is going to do the portfolio on Monday. Yes. Kaya, yes, you sure can. Let me get that for you. Here is the link for the live lesson recordings in case you need it. And today's recording, it usually takes about 30 minutes for it to load. The portfolio is going to be making a model of the solar system. So you can either make it virtually on like a Google slide, or you can make it with actual items. Bye, Adriel. Bye, Ava. Thank you, James. Bye, Kayla. Bye, Cameron. Thank you, Kaya. You too. Bye, Nyla. Sebastian, what's your question? Oh my gosh, Lily, that's funny. Munira, Dr. Fowler, I think she's going to show you a video of a former student that did the hands-on option and one of the virtual option. Bye, Nasir. Oh, the model is due on Monday. Yes, Eli, I'm sorry. I meant to do that. I meant to send the link to everybody. There you go. Bye, Munira. Sebastian, the virtual or hands-on, whichever one you choose, they're both due Monday. You're welcome, Eli. Bye, Eli. Bye, Lily. Anybody else have any questions? Sebastian, you have two portfolios this week. Right. So that's what I wanted to tell you now about yours that is due next week so that you have plenty of time to get it done. But even after it's due next week, the temporary zero won't go until the following week. So we technically have 2 weeks. You're welcome. All right. Any other questions? Have a good day, Sebastian. Thank you. You too. Any other questions? All right. Y'all have a good day.